So let's say you have built an app. You've written the code, everything works fine, and users are happy. But then a bigger question comes into the picture. What about the system design? What happens if tomorrow your app suddenly gets a million users? Most beginners usually think one thing. I'll just increase the size of my server. More CPU, more RAM, bigger machine. And yes, that might work initially, but the problem is this approach does not scale. Increasing server size alone is not going to solve the problem. At some point, you'll hit a limit. And more importantly, you'll still have a single point of failure. So instead of only thinking about code, you actually need to design the system properly. Let me explain this step by step. The first thing to think about is server scaling. If you're using only one server for everything, like handling requests, processing logic, talking to the database, then sooner or later, that one server is going to get overloaded. And if that one server goes down, your entire application goes down with it. That's why using a single server for everything is a bad idea at scale. Instead, we use something called horizontal scaling. In horizontal scaling, instead of making one server bigger, you add more servers. So as the number of users increases, the number of servers also increases. Now the question is, how do users know which server to talk to? This is where a load balancer comes in. A load balancer sits in front of all your servers. Whenever a user sends a request, the load balancer decides which server should handle that request. Its job is to distribute traffic evenly, make sure no single server is overloaded, and improve availability. So even if one server goes down, the load balancer simply stops sending traffic to it and the application keeps running. This is a very important building block in system design. Now let's talk about the database. Just like servers, if you use only one database for everything, it will eventually become a bottleneck. So what we do here is create multiple copies of the database. There is one main database, often called the master or primary database. This database is used only for write operations, like inserts, updates, and deletes. Then we create multiple replica databases. These replicas are used only for read operations. So when users are just fetching data, those read requests go to the replicas. A load balancer or routing layer decides which replica should handle which read request. All write requests always go to the master database. This approach significantly reduces load and improves performance. Now imagine your app grows even bigger. So much data that even a single database or even replicas are not enough. In that case, we use sharding. Sharding means splitting the database into multiple parts. For example, one shard for users with IDs 1 to 1 million, another shard for users with IDs 1 million to 2 million. Each shard stores only a portion of the data. This way, no single database stores everything. Queries become faster, and storage becomes scalable. Sharding is usually introduced when the data size becomes massive. Now let's talk about performance. You might ask, do we really need to query the database every single time? For example, user profile data, popular posts, or frequently accessed information. Fetching this again and again from the database is slow and unnecessary. So instead, we use a cache, commonly called Redis. Redis stores data in memory. So when data is accessed frequently, we store it in Redis. So next time, we fetch it directly from memory. No database hit. This makes the response extremely fast. Databases are powerful, but memory is always faster. Now, what about large files like images and videos? Serving these directly from your main server is a bad idea. It increases load, latency, and bandwidth usage. So instead, we use a CDN, which stands for Content Delivery Network. A CDN copies your content across multiple locations around the world. When a user requests an image or video, the CDN finds the closest server, and that server delivers the content. This reduces latency and improves user experience. This is exactly how platforms like Instagram and YouTube serve media. Now let's talk about application structure. If your entire app is one big codebase, then a single bug can bring everything down. So instead, we use microservices. Each major feature becomes a separate service. For example, login service, messaging service, Reels or feed service. Each service runs independently, can be scaled independently, and can fail independently. So even if the messaging service goes down, login and other features can still work. This improves reliability and maintainability. So in short, when you're building an app for 1 million users, writing correct code is just a starting point. Real scalability comes from proper system design, load balancing, database architecture, caching, CDNs, and microservices. That's why at scale, you don't just need code, you need engineering-level system design.